Today we're going to move on to derivatives part B, the power rule. And this is going to be quite a shortcut for what we were learning last class. So everything we learned last class was kind of the long way to do it. And today we're going to look at the short way to do it. But we can only use it in certain circumstances. And when can we use it? Well, the conditions in which the power rule applies. You may only use the power rule if you have a variable raised to a number, so x squared or 3x to the fifth power, something like that. The variable cannot be located in the denominator of the fraction. We would have to move it to the numerator, and the variable cannot be the exponent, so we can't have 5 to the x power or something like that. So what is the formula for the power rule? So if we're going to take the derivative of f of x, when f of x equals x to the nth power, f prime of x is equal to, we're going to bring the exponent down and make it the coefficient. So we take the n, bring it down, and now it's the coefficient, and we subtract 1 from the exponent. So f prime of x is now equal to n times x to the n minus 1 power. Last time we did a whole bunch of, the limits as things approach 0 and all this stuff, trying to find the slope. Well, we can find the slope this way by using the power rule. Makes things a lot easier. Let's take a look at some examples. So x squared, the derivative of that, we're going to take the 2, bring it down in front, and subtract 1 from 2. So the derivative of x squared is 2x, and we looked at that yesterday or last class, and we figured that out. What about x cubed? Bring the 3 down in front and subtract 1 from the exponent. The derivative of x cubed is 3x squared. What about x to the fourth? Well, 4x to the third. Okay, so far so good. What about some special cases? If we just have x, well, we could think of that as x to the first power, bring the 1 down, and then subtract 1 from the exponent, leaves us with 1 times x to the 0th power, which is just equal to 1. How about 1, or any constant for that matter, is going to be x to the 0th power is equal to 0 times x to the first power, or negative first power. But 0 times anything is 0. So the derivative of any constant is going to be 0. And that's going to be something we're going to want to remember. So these are some simple examples of the power rule, and it's really going to help us to figure out derivatives much more easily. Okay, what about something that's a little trickier? Okay, if we have the square root of x, remember from our Algebra 2 days, that's x to the 1/2 power. Well, we can still use the power rule for x to the 1/2. The derivative of that, we're going to bring the 1/2 in front, and then we're going to subtract 1 from 1/2, which would give us negative 1/2. So 1/2 times x to the negative 1/2, we could rewrite that as 1 over 2 to the x to the 1/2, or 1 over 2 to the square root of x. These are all equivalent answers, but this is probably the simplest form of that. And we don't have to put the square root of x in the numerator. We could, but we don't have to. How about something like this, 1 over x? At the beginning, I said you can't have an x in the denominator. Well, what we can do is we can pull it up to the numerator by 1 over x is equal to x to the negative first power. Again, going back to your Algebra 2 days. Well, the derivative of that, bring the negative 1 out in front, subtract 1 from the exponent. Negative 1 minus 1 is negative 2, and I'm left with negative 1 times x to the negative 2 power. And I could write that as negative 1 over x squared. Okay, well, what happens when we have 2 or more things grouped together? Don't worry, it's not too hard. Addition and subtraction. Well, we can take the derivative of each term separately. Makes things pretty easy. So if I have x squared plus x minus 1. The derivative of that, well, we'll just take the first one first. That's going to be, bring the 2 down, subtract 1 from 2, so it's 2x. The derivative of x is just, remember, we're going to bring the 1 in front, and x to the 0th power is just 1, so 1 times 1 is just 1. And minus 1, remember, the derivative of any constant is 0, so there is nothing here. So the derivative of x squared plus 1 minus x squared plus x minus 1 is equal to 2x plus 1. Okay, so just take the derivative of each term separately. What about if we have a multiplication? What if we have a coefficient out there? Well, so we simply multiply it. So if I have 4x cubed and I want to take the derivative of that, 4x cubed prime, okay, I'm going to take the 3 and bring that down in front and subtract 1 from that. So I'm going to have 3x squared. Well, then I just end up multiplying the 4 that I had before in times 3, and I'm left with 12x squared. So it says when we take the derivative, we just multiply it. Okay, just take that coefficient in front and multiply it by the answer. What if we have things like this? Okay, x times the square root of x prime. We want to take the derivative of that. Well, we're going to have to do some little bit of algebra here before we can do taking the derivative. So we're going to take x times x to the 1/2. Well, that equals x to the 3/2. And now we can take the derivative. Bring the 3/2 out in front, subtract 1 from 3/2 gives us 1/2, and we're left with 3 over 2 times the square root of x. Okay. Important note, the power rule does not work unless the equation is specifically written in the form of the variable to an exponent. Okay, if it is in any other form, you must simplify it. You got to put it in the form that we can use the power rule. So let's look at some examples. Here I have f of x is equal to 3x squared plus 1 over x squared. What's the derivative of that? F prime of x. Okay, we're going to take this prime. So I'm going to take the 1 over x squared, and I'm going to make that x to the negative 2 power. Okay, so I can now take the derivative of this. I can't do it until I do that. So what's the derivative of 3x squared? Well, it's going to be 3 times 2, x to the 2 minus 1, so it's just going to be 6x. Here, I'm going to bring the negative 2 down in front and subtract 1 from that. So minus 2, x to the negative 3, and I can rewrite that as 6x minus 2 over x cubed. What about this example? I've got f of x is equal to the square root of x cubed plus 4x minus 7. I'm going to take the derivative of that. Well, I'm going to rewrite the square root of x cubed as x to the 3/2. So got to remember some of our stuff from Algebra 2. So x to the 3/2 plus 4x minus 7. Well, I'm going to bring the 3/2 in front of the x, subtract 1. So I have 3/2 x to the 1/2 plus the derivative of 4x. Well, that's just going to be 4. And the derivative of negative 7, well, derivative of any constant is just 0. So my final answer is 3/2 times the square root of x plus 4. All right, let's try one that's a little bit harder. All right, so I've got 7x plus 4 over 3x squared. Now, I can't just take the derivative of the numerator and divide it by the derivative of the denominator. It doesn't work that way. What do we have to do? We have to simplify the equation first before we take the derivative. So I've got f prime of x is equal to 7x plus 4 over 3x squared, and that whole thing prime, we're going to take the derivative. I'm going to separate it into 2 terms. Okay, I've got a common denominator, so I'm going to separate it into 2 terms. So here I can divide out one of the x's, so I'm left with 7 over 3x. And here I can't divide anything out. I'm just left with 4 over 3x squared. But now I can take those x's and by making them negative, put them into the numerator. So I've got 7/3 times x to the negative 1 plus 4/3 times x to the negative 2. Now I can take the derivative of that. I'm going to take the negative 1 and put it in front and subtract 1. So I've got negative 7/3 x minus 2 plus I've got negative 2 times 4/3 is negative 8/3, and subtracting 1 gives me an x to the negative 3. And I could rewrite that as negative 7 over 3x squared minus 8 over 3x cubed. So that would be my final answer. So some questions. Can we always use the power rule? No, we can only use it when it's a case of a variable raised to a certain number, okay? So it's going to be x to the third or 14x squared, something like that. When does the power rule does not work? Okay, if your problem involves multiplication, division, okay, you've got to separate it into terms that you can use the power rule. It doesn't work on trig functions, log functions, anything complicated, okay? So you'll learn more about that when you get to calculus class. Oops. But for now, we're going to just do it of a variable raised to a number. Okay, why is the derivative of a constant 0? But if we ignore the constants, if they're multiplied by a variable. Okay, well, we'll look at this in the next lesson. But right now, just accept that when you have a variable in front, a constant in front, you multiply it. But when it's just a constant by itself, well, then it becomes 0 when we take the derivative. Okay, so we're now going to switch over to the in-class worksheet, and we'll look at that.